Let's solve inequalities that involve radicals. For example, let's solve the following inequality for x. All right, so what does the left-hand side here equal? Most students will say that it equals x minus 6, which is not true. In fact, it equals the absolute value of x minus 6. That is, the square root of something squared is only equal to that thing if that thing is greater than or equal to 0. Otherwise, it's the negative of it. Or the square root of y squared is equal to the absolute value of y. For example, the square root, say, of 2 squared is equal to the square root of 4, which is 2. So yes, the square root of y squared is y. But what about the square root, say, of negative 2 squared? If that y is negative, this is the square root of 4, which is 2. So these aren't equal, they're the negatives of each other. So be very careful here. It's a very common mistake. Therefore, the inequality that we need to solve is that the absolute value of x minus 6 is less than or equal to 9. And remember, when solving absolute value inequalities, this means that negative 9 has to be less than or equal to x minus 6, has to be less than or equal to 9. So this translates into this compound inequality. And now we can add 6 everywhere, which gives us negative 9 plus 6 is less than or equal to x is less than or equal to 9 plus 6, or negative 3 is less than or equal to x is less than or equal to 15. Which we could write in interval notation as the interval negative 3 up to 15. Or we could even graph it. The solution set would be the interval from negative 3, including negative 3, all the way up to 15, including 15. So just be really careful that you use the absolute value here. All right, let's see another example. Let's solve this inequality for y. Again, we have the square root of something squared, and be careful, remember, it's the absolute value of that thing, which needs to be greater than 5. So when solving absolute value inequalities, if we have the absolute value of something is larger than 5, then that means that that quantity is either larger than 5 or that quantity is smaller than negative 5. And now we'll solve this compound inequality by working each side separately. Solving this first inequality, we subtract 3 from both sides, which gives us negative 2y is greater than 5 minus 3, or negative 2y is greater than 2. And now we'll divide both sides by negative 2. But remember, we have to flip or reverse the direction of this inequality, which gives us y is less than negative 1. All right, and what about the second inequality? Again, we'll subtract 3 from both sides, which gives us negative 2y is less than negative 5 minus 3, or negative 2y is less than negative 8. Again, dividing by negative 2. And flipping or reversing the direction of our inequality gives us that y is greater than 4. And because these inequalities are joined by the word or, our solution here will be the set of all y that make at least one of these inequalities true. So graphing this gives us the following. Let's say this is negative 1. Less than negative 1, we do not want to include negative 1, so we put an open circle, and less than we go to the left. And let's say this is 4. We do not want to include 4, so we put an open circle greater than, we go to the right, which would be our answer here. And in interval notation, we could write negative infinity up to -1, open parenthesis because we don't want to include -1, union, again, open parenthesis at 4, up to infinity. So just be very careful that you use this absolute value here when starting off. Thank you, and we'll see you next time.